Hello everyone, in this video we'll be solving problem 1394, find lucky integer in an array. The problem statement is to return the largest lucky integer from an array.
And return 1 if there are none.
A lucky integer is a number that has the frequency in the array equal to its value. For example, if the value 2 occurs twice in the entire array, it is a lucky number.
And we are looking for the largest lucky number, which implies that there could be multiple integers which are lucky in the given array.
Looking at example number 1, the lucky number here is 2 because it occurs twice. While in example number 2,
The largest or the highest lucky number is 3, even though we have 2 and 1 which are also lucky numbers.
I hope you are able to understand the problem statement. It is very straightforward and easy to solve. So let's switch to whiteboard and discuss the approach.
The simplest way to solve this problem is to use additional memory that will hold the frequency of each number that occurred in the original array. And once we know the frequency of the number that occurred, we can compare it with the corresponding index to check if it's a lucky number.
Let's do a quick dry run with this input. In the problem statement, it is given that the size of the input array or the numbers in the input array will not be greater than 501.
So let's start with creating the frequency array of size 501 to avoid running into our index out of bounds. Now I'll start iterating through the input array, and the value at each position will become my index, and the corresponding value in the frequency array will be incremented. For instance, let's start with I pointing at 0, that is, it's pointing at 1 in the original array. So the corresponding value of I in the frequency array currently is 0, so I'll increment it by 1. That is, frequency of 1 is now 1. Now we'll increment the pointer to the next value. So I is equal to 1, the value is 2. So frequency of 2 element will be incremented by 1. The next element in the array is 2, so I'll update its corresponding frequency by 1. So the new value will be 2. The next value in the array is 3, so frequency of 3 will be incremented by 1. To save time, I'll quickly update the frequency for 3, that is the remaining elements in the array. Now that we know the frequency of each number, now we need to identify which one is the lucky integer. So we'll start iterating through the elements in the frequency array and compare the index with the corresponding value. And if the two value matches, it means that number is a lucky integer. If we are iterating from left to right, we need to iterate through all the possible combination as we are looking for the highest lucky number and save the value in an output variable which will be returned at the end. One tweak or improvement we could do is to run an iteration from the last element towards the first element. In that case, if we encounter a lucky integer, we don't need to continue the iteration any further because that's going to be the largest number. That approach could save some of processing, but overall time complexity will still stay the same. With this solution, our time complexity is going to be O of n, where n is the number of elements in the input array. This is because we are running two iterations, one to iterate through all the elements in the input array and the second one to iterate through the frequency array. Because the size of the input array is not going to be greater than 501, we could also say that time complexity is O of 1, that is constant time. While the space complexity is O of 1, as we are using this frequency array of constant size, that is 501, so we can represent it by saying the space is going to be constant space.
I hope you are able to understand the explanation. Let me show you how we can implement this approach using Python.
In this Python implementation, I have created a variable frequency which is of type array and setting the length to 501.
After that, I am recording the frequency of all of the elements in the input array by running a for loop.
Now that we know the frequency of all of the elements in the input array, I am starting a new for loop on the frequency array to calculate the lucky number. Inside the loop, I am checking if the index I is it equal to its corresponding value in the frequency array. If yes, it means it is a lucky number. As the loop continues, the value of the lucky number will be updated with higher values which is still matching the lucky number criteria.
Once the for loop is complete, I am returning the lucky number as our output. This code, when submitted on LeetCode, beats 32% of the submissions in terms of runtime and 96% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.